Hey everybody, welcome back. So before we start today's video, I want to just give you guys a disclaimer. We're doing power today. Specifically, we're doing a three-phase power today. I'm not an electrician. I'm not here to give you any type of advice as to how you should build a three-phase power distro or anything regarding power with your rig. This is me telling you, if you don't know what you're doing, hire an electrician or buy a product from someone who actually knows what they're doing. So to the YouTube comment section, chill out. This is supposed to be for entertainment purposes only. A lot of things or a lot of people that I've talked to in the world, power is a mystical force for them. So I maybe just want to demystify a little bit about three-phase power specifically. If you work for a sound company, chances are your amp racks are probably using an L21-30 connector, which is a 5-wire, three-phase connector with 3 hots, a neutral, and a ground. I've gotten some requests on some other videos just to show a three-phase power distro, and I'm prototyping this project for us here at LM. So, you know, before we release projects or products into the world, oftentimes I'm the beta tester for them. So. A lot of the products that we build have just basically arose from a need that I've either had as a sound engineer or we've gotten customer requests. So this particular request or this particular design is actually coming from a customer, and I thought, well, what you're asking for is cool. I'll modify it a little bit and just make it a standardized product for us. So this is what we're calling the 3.2 power distro. So we already have a 2130 distro that's standardized. You can check the link here. If you want to check that out, or here, I don't know what side that's going to be on, but anyway, upper right-hand corner and in description below if you want to check out our standard 2130 distro. This is designed just to be a bit more accommodating. Our standard 2130 distro just has Edisons on the back, and because of that, we have to use a 20 amp breaker for everything. So because the outlet is not rated for 30 amps, so we have to match the load rating of the outlet to the breaker. This one has one dedicated 30 amp L530 on the back, so if you have a bigger amp that's powering your subs or something like that you need 30 amps for, we can accommodate that, and then it also has a cell phone charger and all that other kind of stuff. So anyway, we're going to build this now. I'm going to show you the finished one first, and then we'll go and build a new one. So check it out. Okay, so this is our built D32 power distro rack pack. This features a L21-30 inlet, which I mentioned previously. It gives us 3 hot lines, a neutral, and a ground. This loops into an output, so if you want to have amp racks that loop on, or systems that loop on to this. The other thing you can use this for is courtesy power. In previous videos, you've seen me make completely non-safe and, well, I wouldn't say non-safe, but non-sanctioned breakouts that basically take 30 amps, an L21-30, and break that into 3 separate circuits, which a lot of people do with that. We also have a dedicated courtesy power right here. So this is a Leviton outlet that gives you 2 Edisons, a USB-A and a USB-C. Now, the way that I like to do these courtesy power outlets is I like to spec a separate 5 amp pot breaker on that. And that's just so if somebody comes and plugs into your distro, they can't do something dumb with your courtesy outlet. So if the distro is under load and it's powering whatever the system is behind this, and somebody, I want to make sure that somebody doesn't come and plug another rack in or something crazy like a heat gun or something like that to put this in here. So I want to be able to blow this 5 amp breaker before you blow the 20 or the 30 amp breaker that are the master breakers. So the way we have this distro set up, there are 3 separate phases, X, Y, and Z. There are 3 separate breakers over X, Y, and Z. The X breaker is 30 amps. The Y and the Z breakers are both 20, and I'll explain that to you in 1 second. Let's turn this thing over and look at the back. Okay, so looking at the back here, the difference between our standard 2130 distro and this one is, one, you get the courtesy USBs on the front, and then also on the back you have this L520 twist. There's also this True 1 and then there is a normal complement of Edisons. So the X phase, this is dedicated. So there's only one thing on the X phase, and that's this L520. And then this is protected by a 30 amp breaker. I mean, and again, this came from a customer request. A customer bought our normal L21-30 distros, and he was saying that he was popping his 20 amp breaker with his sub amp. And I said, cool, no problem. We'll put an L5 on the back. So the reason why we use 20 amp breakers is even on a 30 amp inlet circuit is these outlets are only rated for 20 amps. Can they handle 30 amps? Of course they are. I know that's what you're thinking. But if you're building something for somebody else, you have to follow the normal safety guidelines of normal NEC code. So the way that we have this split up, again, X is a dedicated 30 amp circuit. We've got 8 duplex outlets that are on the Y phase. Z handles another 4 Edisons, this true one, and then also the courtesy on the front. And then all of the phases are also labeled. Here's YY. Oh, it's YYZ or YYZ for all you Rush fans. Anyway, I will show you how we build this. Okay, so this is the front panel disassembled here. Again, this is just some basic preloading of everything so that it's just not boring. What we do is there are phase indicators here. So there's a positive and a negative for each one of these little LEDs. Now these actually do run at 120 volts AC. So we just put these into each of the phase circuits so that you know when one of the LED lights is illuminated that the power is present there. So these are the breakers, you know, on the back, on the master breakers here. These are terminals, and then these are spades here on the back. So this is just a standard Decorah punch. You know, obviously these are the 30 amp series of Hubble inlets. So the back chassis goes together just like this. So what I like to do with these is I like to build the back chassis first. Now the thing that I'm experimenting with on this run, so I've built 2 of these already, so this is my 3rd one. I'm trying to get my build procedure done. So generally for these prototyping kind of things, I'm the first one that builds them, comes up with the build procedure. If we have to go back and adjust any of the engineering on the metalworking, we do that. So you're in my prototyping phase right now. So the thing that I wanted to experiment with on this particular project is using a bus bar for my grounds and for my neutrals. Since there's a common ground and a common neutral, generally speaking, when we do these, we just jump things. We'll just jump neutrals. We can share them, and we can jump grounds because there's enough. But what that eventually gets into doing is, you know, you have the Edisons have, you know, double stacked ring terminals on their ground terminal and stuff like that. So I'm experimenting with the bus bar, which on my first prototype I built without it. My second one I built with it. They work really well, actually. It's very tight in the box. What I ended up doing was just drilling by hand these sets of holes that match my ground bus, and then the other one for my neutral bus. I don't know that I'm going to do those in production. I don't think it saves me that much time. And the cable in the interior of this, as you'll see, is extremely dense. So in order to keep this in a 2U chassis, which, let's see, is this a 6.5? This is a 6-inch deep back box. So to keep it small, the wiring is very dense. In an ideal world, this would be a 3U. I know that there are a lot of people who build their distros as 3U, and I completely understand why, because they're extremely difficult to build in this 2U chassis, which is one of the reasons why they're expensive, just because they're very time consuming. But anyway, I'm going to stop yakking, and I will get everything populated. So here we go. All right, y'all. Well, this is finished up with side one. So anything that's a blue wire here, this is our Z phase. The red wire is our Y, and our black wire is our X phase. So again, you know, the grounds are pretty long at this point. There's going to be a bus bar that ends up around this area. So I mean, as soon as I can get these grounds trimmed, the better. So just in case you're curious, we do ground the chassis in two different ways. So if we're using a bus bar, there is a little copper tab that's on the bottom of that bus bar that does touch the chassis. And then we also have a separate chassis ground that goes right here. So anyway, I'm going to get the front roughly populated. Or actually, I'm going to get the bottom on and get the bus bars installed. We'll get all of the hots, or excuse me, the grounds and the neutrals terminated at that bus bar, and that'll clean all of this up to make it a little bit easier to work with. So here we go on that. All right, y'all. Well, that wraps this one up. So here is the finished distro with its breakers tripped. So anyway, you can see that this is a pretty time-consuming process. So in case you find yourself looking for a distro for your amp rack and you're wondering, man, why are these so expensive? Well, that's why. And this is girthy too. This thing is not light. But anyway, you know, if you like what you see and you want to buy this from us here at LM, there is a link in the description below for that. You know, we're a small mom and pop company. My family owns the company, so I've been here my entire life building cases and stuff like this. So if you do want to support me, you can support me indirectly by that. But anyway, again, just to echo what we had at the beginning of the video, I'm not an electrician. If you're I'm sure a few of you probably have some commentary on the way that I do this, but you know, if you're looking at this, please don't do a project like this unless you are A, comfortable, or B, have some supervision from somebody who actually knows what they're doing. So again, I appreciate y'all. Thanks for watching. We'll catch you on the next one. Bye.